There's a farming method that produces 3 times more food than modern agriculture, using 0 fertilizers, 0 pesticides, and 90% less water. It builds soil instead of destroying it. It increases biodiversity rather than eliminating it. It works in deserts, on mountainsides, and in climates too harsh for conventional farming. The United Nations calls it one of the most productive agricultural systems ever developed. Every ancient civilization used this method to feed millions of people for thousands of years. The Incas built an empire on it. The Chinese sustained dynasties with it. Indigenous communities across 6 continents perfected it over centuries. Agricultural archaeologists find evidence of this system feeding dense populations where modern farming would fail completely. Then, something happened that changed everything. In less than 50 years, this proven method was abandoned across most of the world and replaced with industrial monocultures that produce less food while destroying the land. It wasn't because the old system stopped working. It wasn't because something better was invented. A farming method that made communities completely self-sufficient threatened every part of the emerging agricultural industry. Seeds companies couldn't sell to farmers who saved their own varieties. Chemical companies couldn't sell to farmers who built their own fertility. Equipment manufacturers couldn't sell to farmers who worked with hand tools and natural systems. This is the story of the farming method that still outperforms everything we call modern agriculture, and why it was systematically erased from memory. Welcome to Forgotten Fields. If you want to understand how the most productive farming system in history was deliberately buried, stay until the end. Let me take you to the Andes Mountains, 1530. Spanish conquistadors climbed narrow stone terraces that seemed to defy gravity, carved into mountainsides 12,000 feet above sea level. What they find contradicts everything they thought they knew about agriculture. Thousands of distinct potato varieties grow in organized plots, each one perfectly adapted to its specific microclimate. Quinoa fields cascade down slopes that should be impossible to farm. Corn grows at altitudes where European crops would freeze. The terraces capture every drop of precious rainfall, channel it precisely where needed, and prevent any soil erosion. How do you feed so many people on such steep land? A Spanish chronicler asks through a translator. The Inca farmer gestures to the elaborate system surrounding them. We grow many different plants together, he explains. Each one helps the others. The mountain teaches us where each should grow. We never fight the land, we dance with it. The Spanish didn't understand what they were witnessing, but modern agricultural scientists do. This was polyculture, the most sophisticated farming system ever developed, and it produced more food per acre than anything we've achieved since. The method I'm describing goes by many names: polyculture, intercropping, companion planting, food forests, indigenous agriculture. The specific techniques vary by region, but the principles remain the same. Instead of growing single crops in isolation, farmers grow multiple species together in carefully designed relationships. In Central America, indigenous farmers still practice the Three Sisters method, growing corn, beans, and squash together. The corn provides a natural trellis for beans. The beans fix nitrogen that feeds the corn and squash. The squash leaves shade the soil, retaining moisture and suppressing weeds. Together, they produce more food than any of them could grow alone. In Asia, rice farmers developed aquaponic systems thousands of years before the word existed. Fish swimming in flooded rice paddies provide fertilizer for the grain while producing protein for families. Ducks eat pests and weeds while adding more fertility. The system produces rice, fish, duck eggs, and duck meat from the same space modern farming would use only for rice. In Africa, farmers intercrop dozens of species in patterns that look chaotic to modern eyes, but represent sophisticated ecological engineering. Tall trees provide shade and windbreaks. Medium-height shrubs produce nuts and fruits. Ground-level plants include grains, legumes, and vegetables. Root crops grow beneath the surface. Every layer contributes to the system's productivity and stability. These polyculture systems consistently outproduce monoculture crops when measured properly. A Mexican study found traditional milpa systems producing 1.73 times more food per acre than modern corn monocultures. Research in Africa shows intercropped fields yielding 2 to 3 times more nutrition per square meter than single crop systems. Chinese rice fish polyculture produces 12% more grain plus substantial fish protein compared to rice alone. But productivity isn't the only advantage. Polyculture systems are dramatically more resilient than monocultures. When one crop fails due to weather, pests, or disease, others continue producing. Diversity provides insurance that single crops cannot offer. The ecological benefits are equally impressive. Polycultures build soil through diverse root systems and natural composting. They require no synthetic fertilizers because legumes fix nitrogen and deep-rooted plants mine minerals from subsoil. They need no pesticides because pest species can't establish in diverse plantings. They use less water because ground cover reduces evaporation and diverse roots access moisture from different soil layers. So, if this system is so productive, so sustainable, so proven by thousands of years of success, why did most of the world abandon it for monoculture farming? The answer reveals uncomfortable truths about how our food system was restructured for profit rather than productivity. The first factor was mechanization. Polyculture systems require knowledge, observation, and hand labor. They can't be mechanized easily because different crops mature at different times and require different handling. Industrial agriculture preferred systems that could be planted, sprayed, and harvested with large machines operated by unskilled workers. The second factor was standardization. Industrial food processing required uniform inputs delivered in massive quantities. A processing plant designed for corn couldn't handle the diverse grains, beans, and vegetables that polyculture systems produced. It was easier to demand that farmers grow single crops than to adapt processing to handle diversity. But the deeper reason was economic control. Polyculture farmers were largely self-sufficient. They saved seeds from multiple species, built their own soil fertility, and controlled their own pest management. They rarely needed to purchase anything to keep farming. This independence was intolerable to the emerging agricultural industry. Companies needed customers, not self-sufficient farmers. The solution was to convince farmers that monoculture was more efficient, more modern, more scientific than traditional polyculture. The campaign began in agricultural colleges and extension services. Professors who had never practiced polyculture declared it primitive and inefficient. Extension agents promoted simplified systems using purchased inputs. Research funding flowed exclusively to monoculture studies, ensuring that polyculture appeared less productive in academic literature. Government policies accelerated the transition. Subsidies supported single-crop farming while ignoring diverse systems. Crop insurance covered monocultures, but not polycultures. Agricultural loans required simplified business plans that polyculture's complexity couldn't satisfy. The transformation happened remarkably quickly. In just 2 generations, farming communities abandoned agricultural systems that had sustained them for centuries. Traditional knowledge was lost as children learned industrial methods instead of indigenous ones. Seed varieties disappeared as farmers switched to commercial hybrids. But polyculture never completely vanished. Indigenous communities in remote areas continued practicing traditional methods. Small-scale farmers in developing countries maintained diverse plantings because they couldn't afford industrial inputs. Permaculture pioneers in developed countries began rediscovering and documenting polyculture principles. Today, a quiet revolution is growing. Climate change is making monocultures increasingly unreliable, while polycultures prove more resilient to extreme weather. Soil depletion from intensive monoculture is forcing farmers to seek sustainable alternatives. Rising input costs make the self-sufficiency of polyculture systems increasingly attractive. Modern research is confirming what indigenous farmers always knew. Studies from universities worldwide document polyculture's superior productivity, sustainability, and resilience. The UN's Food and Agriculture Organization now promotes agroecological methods that are essentially updated versions of traditional polyculture. Starting a polyculture system requires thinking differently about farming and gardening. Instead of asking, what crop should I plant? You ask, what plants work well together? Instead of fighting nature with chemicals, you design systems that work with natural processes. Begin by observing your land carefully. Notice which areas get morning sun versus afternoon sun. Where does water naturally flow? Which spots stay moist while others dry out? These observations guide plant placement in polyculture design. Choose plants with complementary needs and functions. Tall plants that need full sun can shade shorter plants that prefer partial shade. Deep-rooted plants can be partnered with shallow-rooted ones. Nitrogen-fixing legumes can support heavy-feeding vegetables. Plants with strong scents can confuse pests targeting other crops. The Three Sisters combination works in most temperate climates and provides a simple introduction to polyculture thinking. Plant corn first, allowing it to establish. And when corn reaches knee height, plant beans around the stalks. At the same time, plant winter squash or pumpkins around the perimeter. The system maintains itself with minimal intervention while producing 3 different food crops. Food forests represent polyculture's ultimate expression. These systems mimic natural forest ecosystems but produce human food instead of timber. Tall fruit and nut trees form the canopy. Smaller fruit trees create the understory. Berry bushes fill the shrub layer. Herbs and vegetables grow at ground level. Root vegetables occupy the soil layer. Climbing vines use trees for support. Established food forests produce abundant harvests with minimal maintenance. They require no external fertilizers because the system generates its own fertility through leaf drop and nitrogen fixation. They need no pesticides because diversity prevents any pest from dominating. They use little water because tree canopies reduce evaporation while deep roots access groundwater. The economic benefits of polyculture extend beyond reduced input costs. Diverse systems produce multiple income streams throughout the growing season instead of single large harvests. Risk is distributed across many species rather than concentrated in one crop. Local food systems value the diversity that polycultures naturally provide. But perhaps most importantly, Polyculture systems restore the relationship between farmers and land. Instead of imposing industrial simplicity on complex ecosystems, polyculture works with natural complexity to achieve remarkable productivity. Farmers become ecosystem designers rather than chemical applicators. Every garden that moves toward polyculture principles challenges the industrial agriculture narrative. Every successful intercropping experiment proves that nature's complexity is more productive than industrial simplicity. Every food forest that feeds families without external inputs demonstrates the self-sufficiency that agricultural corporations fear most. The farming method that fed ancient civilizations and still outproduces modern agriculture in properly designed systems offers a pathway beyond industrial dependence. It requires learning rather than purchasing, observation rather than application, partnership with nature rather than domination over it. Now you know what they didn't want you to know. Polyculture still works. The knowledge exists, preserved by indigenous communities and rediscovered by ecological farmers. You can begin designing polyculture systems today, starting small and building complexity as your understanding grows. This isn't just about farming. This is about remembering that human societies can be as diverse and resilient as the agricultural systems that sustain them. Monocultures create vulnerability, polycultures create abundance. The choice is yours. You can continue supporting agricultural systems that simplify ecosystems into profitable packages. Or you can begin creating the kind of diverse, productive, self-sufficient food systems that sustained our ancestors and could sustain our descendants. Start small. Plant a Three Sisters garden. Notice how the plants interact and support each other. Observe how the system maintains itself with less work than separate monoculture plots. Experience the abundance that emerges when you work with natural complexity rather than against it. The farming method that once fed empires has been waiting patiently for communities to rediscover its potential. The question isn't whether polyculture works. The question is whether you're ready to grow food the way nature intended.